Hi everyone. This short video is intended to introduce you to the SimBio software and also walk you through the first exercise in your lab manual. So before you go through this exercise, you'll want to first read the introduction to the simulation. It's on page 78 and 79 of your lab manual. So once you've downloaded the SimBio software from the course Blackboard site and installed it on your computer, you want to open it and then select the Liebig's barrel and limiting nutrients simulation exercise. That'll bring you to the screen that I'm showing you here. And then you'll want to select the growing phytoplankton exercise from this upper menu. You can follow along on page 80 in your lab manual at this time. So you'll notice the simulation screen has several components. First we have this chemostat. And what this is a tank in which microorganisms can grow. And it has an inflow as well as an outflow for water and nutrients, yet the overall volume of the chemostat is going to remain the same throughout the simulation. Next we have this area down here, nutrient input rates for nitrogen, phosphorus, and silicon. And you can change these input rates, and what are shown here are just the defaults for the simulation. Next up here we have population sizes over time for these three different types of phytoplankton you'll be looking at: green algae, cyanobacteria, and diatoms. The axes of this figure, time in hours on the x-axis, and the y-axis is population size index. And the index simply means that it's scaled relative to the other two phytoplankton that are present. And then finally, we have nutrient levels over time for nitrogen, phosphorus, and silicon. These are the nutrients that you're going to be adding to the tank. And again, we have time in hours in the x-axis, and the y-axis is nutrient concentration index. And then lastly, at the bottom of your screen, you have the control panel. This is where you can start a simulation, stop the simulation, reset the simulation, change the speed of the simulation, look how long the simulation has gone on for, add microorganisms, and also test your understanding. To start the exercise, click on each of the three types of phytoplankton to learn a little bit more about their biology. Then pause this video to answer the questions 3.1 to 3.3. So next, let's run the simulation first with no phytoplankton in the chemostat and just look at the nutrient levels. So to do that, I'm going to click Go and look at the nutrient levels as time elapses. As you can see, this looks like one line, but it's actually three on top of each other. So while this simulation is running, let's double the input rates for each of the nutrients and watch what happens. Notice I'm pressing Set every time I double an input rate. So what you can see is that the nutrient levels rise up to a new value which is twice the initial concentration. So now let's add some phytoplankton. Before we do this, we have to reset the simulation and reset the nutrient levels to default. So I'm going to stop the simulation, reset the simulation, and then reset the nutrient levels to defaults. So to add phytoplankton, you're going to click on the Add Algae button. You can add algae to the chemostat by clicking individually in here, or you can click and drag to add a bunch. So I'm going to add, let's say 20. So before you run the simulation, first fill in the first two columns in data table 1 on page 81. And the input rates refers to this, of course, and then the initial nutrient concentrations are shown here. Now we're going to run the simulation for exactly 100 hours by pressing the Step 100 button. So you'll notice a few things. First, the green algae population grows initially, and then it stabilizes at this value. It looks like around 80. And you can click on the figure to look at these exact values here. Second, over time, the level of silicon remains the same, but nitrogen as well as phosphorus go down, and they stabilize around the same point that the algal population stabilizes. So now record these final nutrient concentration values, shown here, in the third column of Table 1. So if nutrient availability is restricting growth of the algae, we would expect algal population size to increase if we added more nutrients, right? Well, let's do that. So without resetting anything, let's double all of the input rates. And step forward another 100 hours. All right, so if we look at the algae, we can see that the algal population increases again and stabilizes at a new higher value. The value looks like it's around 170 or so. So this is evidence that nutrient availability was restricting algal population growth. Now look at the nutrient levels over time graph and compare the nutrient concentration values to the third column in Table 1. What you can do is compare these values here with the values after 100 hours. And you'll see that when doubled, nitrogen and silicon concentrations increase over time and stabilize, whereas phosphorus remains low, around 30 or so, even though the input rate was doubled. So this suggests it was used up by the algae just as fast as it was being added to the chemostat. So what this reveals is that phosphorus was limiting growth of algae in this example. Okay, so now it's up to you to complete exercises 2 and 3, Liebig's Law and Food Fight. Make sure you answer all the questions in your lab manual and also complete the pre-lecture Poll Everywhere questions.